Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we are required to evaluate the orthographic projections of a line PQ, and this line PQ happens to be parallel to the horizontal plane and perpendicular to the vertical plane, and in this case the two ends of the line, that is P and Q, they happen to lie in different quadrants as well. So here point P lies in the quadrant 1 and point Q of the line, it happens to lie in quadrant number 2nd. So let us read out the statement of the problem. So line PQ, it is 80 millimeter long and it is normal to the or perpendicular to the vertical plane. So whenever a line happens to be perpendicular to the vertical plane, so this line will be parallel to the horizontal plane. So onto the horizontal plane, that is in the top view, we are going to obtain the true length of this particular line, and this line will also happen to be parallel to the profile plane. So into the profile plane as well, we will be obtaining the true length of this line, that is 80 millimeter, in the side view projections over here. So another information which is available with us, that this line PQ, it happens to lie 30 millimeter above the horizontal plane. And another special feature about this particular line has been provided to us, that is 1/4 of the line, it is lying in the first quadrant, while the 3/4 of the line will be lying in quadrant number 2nd. That is, out of 80 millimeter length of the line, so 20 millimeter length of the line will be lying in quadrant number 1, while the 60 millimeter length of the line, it is going to lie in quadrant number 2nd. So with this information, we are required to draw the front view projections of the line, top view projections of the line, and the left hand side projections of the line PQ in this particular case. So here first of all, let us evaluate the 3D spatial representation of this line using the horizontal plane, vertical plane, and the profile plane over here. So as we can see that this is the horizontal plane, vertical plane, and the profile plane, and we have been provided with this information that this line, it is normal to or perpendicular to the vertical plane. This is first thing which has been provided to us. Second thing which is available with us, the distance of this line above the horizontal plane, it happens to be 30 millimeter, right? So distance of this line above this horizontal plane happens to be 30 millimeter, and this line PQ happens to be parallel to the horizontal plane, so that into the horizontal plane, that is the top view projections, we are going to obtain the true length projections of this particular line. And since one of the ends of this line P is located in quadrant number 1 and another end Q of this line, it is located in 2nd quadrant, and so far as the line location is concerned, we have been provided with this information that 1/4 of this line, so 80 millimeter is the overall length of the line. So 1/4 length of the line, which means that 20 millimeter length of the line, it lies in quadrant 1, whereas the 3/4 length of the line, that is 60 millimeter length of the line, will be lying in quadrant number 2nd over here. So the front view projections of this line will mean that you are going to get point P dash Q dash coinciding with each other in the front view obtained on the vertical plane, and this point P dash Q dash will be obtained at a height of 30 millimeter above the XY reference line. So we can see points P dash and Q dash, they have been located onto the vertical plane at a height of 30 millimeter. And so far as the top view projections are concerned, please check. Point P in the top view will be located in the first quadrant, 20 millimeter in front of the vertical plane. Similarly, point Q will be located onto the horizontal plane, 60 millimeter behind the vertical plane in the quadrant number second. Now we know from the basic theory of projections that this front side of the horizontal plane, it has to be rotated clockwise in the downward direction, and this side of the horizontal plane, that is behind the vertical plane, it has to be rotated in the clockwise direction in the upward direction over here. So this will be rotated upwards, and this portion of the horizontal plane has to be rotated downwards. So we will be getting point P of the plan located 20 millimeter below the XY reference line, and the plan projection corresponding to the point Q, it will be located 60 millimeter on the upper side because of the rotation of this portion of the horizontal plane in the clockwise direction and in the upward direction over here. So we can see because of the downward rotation, so this point P which has been projected over here, it will be projected downwards 20 millimeter below the XY reference line. So here point P of the plan will be obtained. Similarly, point Q, it is lying 60 millimeter behind the vertical plane. So 60 millimeter behind the vertical plane, this distance, it will be rotated in the upward direction. So this distance of 60 millimeter will be drawn 60 mm above this XY reference line. So this way, the top view projection will be 20 millimeter. It will be lying below the XY reference line to locate point P, and 60 millimeter point Q will be located above the XY reference line over here. So the front view projections we have discussed into the 3D spatial coordinate locations over here, and the top view projections also we have discussed over here. Now first line PQ, it happens to be parallel to this profile plane, and when we project this particular line onto the profile plane using the left hand side view projections over here, so this point P, it will be projected over here as P double dash. This point Q will be projected over here onto the profile plane as Q double dash. So we can see this is the location of Q double dash. This is the location of the point P double dash. So having obtained the points P double dash and Q double dash onto the profile plane, now we can join P double dash with Q double dash over here, and we obtain the true length projections of the line in the side view projection. So we are going to get true length projections of the line in the top view, true length projections of the line in the side view projections, and point view projections of this line in the front view projections over here. So now let us proceed with the construction of the orthographic projections. So in order to obtain the orthographic projections corresponding to the line PQ, in which the 2 points P and Q, they happen to lie in different quadrants. So we have to draw first of all the XY reference line, X1, Y1 reference line. Now in this case, since the 2 points, they are located in the different quadrants, so the transfer line which we are going to use in this case will be also extending into 2 quadrants over here. So here, this inclined transfer line we are going to use in order to transfer the distances of these 2 points P and Q from the vertical plane, from the top view projections into the profile view projections over here. So let us now start with the orthographic projection. Now let us first of all draw the true length projections of this particular line. So we know that since 1/4 of the line, it happens to lie in quadrant 1. So this distance 20 millimeter, as you project it onto the horizontal plane, it will lie on the horizontal plane as point P over here. So this portion of the horizontal plane has to be rotated downwards. So this point P will be located 20 millimeter below the XY reference line. So we have taken a distance of 20 millimeter below the XY reference line so that we can draw the true length projections of the line in the top view projections over here. And now we also know that 3/4 of the line, that is 60 millimeter length of the line, lies in the quadrant number 2nd. And in the second quadrant, the line lies behind the vertical plane. So as we look at this point Q from the top, so this point Q will be projected onto the horizontal plane at a point Q, and this small q will be located 60 millimeter behind the vertical plane. And now this portion of the horizontal plane has to be rotated clockwise upwards. So this distance of 60 millimeter has to be rotated in the upward direction, because in the second quadrant, the top view projection as well as the front view projections of a point, they will be lying above the XY reference line. So the distance of point Q from the vertical plane is 60 millimeter. So we will be taking this distance as 60 millimeter, or else take a distance of 80 millimeter from the point Q, because the point P and point Q, they are separated by a distance of 80 millimeter, because the true length of the line happens to be 80 millimeter. So either we can take a distance of 60 millimeter behind the vertical plane, take it upwards. Once again, the total distance between points P and Q in the top view projections will become 80 millimeter over there. So having obtained the top view true length projections of this particular line onto the horizontal plane, now we can join points P and Q over here. So this top view projection of the line PQ, it represents the true length projections of the line. Now the front view projection of the line, as we have discussed, they will lie as P dash Q dash, that is P dash and Q dash points, they are going to coincide with each other onto the vertical plane at a height of 30 millimeter above the XY reference line or above the horizontal plane. So we have taken a distance of 30 millimeter, we'll mark a point over here, and this point will be labeled as P dash and Q dash. So the front view of the line, it is available with us as a point view, whereas the top view of the line PQ, it is available with us as a true length projection over here. Now let us proceed with the projection of the side view, that is the left hand side view. So we know that whatever is the height corresponding to the point P or Q is there. So the side view points P double dash and Q double dash, they will also be available with us at the same height. So we are going to draw projection lines from the points P dash and Q dash and extend this horizontal construction line or a projector line into the profile view projection over here. So into the profile view projection, we have extended this line at a distance of 30 millimeter above the horizontal plane. Now we have to transfer the distances corresponding to the plan into the profile plane over here. So please check point P, it is located at a distance of 20 millimeter in front of the vertical plane. We can check it over here. We can check it out even in the model. So in the 3D spatial model that we have drawn, point P is located 20 millimeter in front of the vertical plane. Now this distance front of the vertical plane, we have to transfer it into the profile plane as 20 millimeter from this particular vertical plane over here. So this distance in the top view will be translated as this 20 millimeter distance in the profile plane. So this is 20 millimeter in the top view distance. This is 20 millimeter in the profile view distance that we have converted. So what we have done, we have drawn a horizontal projector line starting from the point P till it intersects with this transfer line which has been drawn at an angle of 45 degree. So wherever this horizontal projector line, it intersects with this transfer line, now we are going to draw a vertical projector line through this point so that this projector will be extended up to the locus line corresponding to the point P dash in the front view. So this height of 30 millimeter, it is corresponding to point P dash. This distance of 20 millimeter in front of the vertical plane we have transferred from the top view. So top view distance of 20 millimeter from the vertical plane has been transferred to the profile view distance of 20 millimeter from the vertical plane over here. So the intersection of these 2 points, they will give us the location of the point P double dash in the profile view projection over here. So P double dash point has been located, and let us check the coordinates of this point. 30 millimeter above the horizontal plane, this point lies. 20 millimeter in front of the vertical plane, this point is lying over here. Similarly, corresponding to the point Q, again point Q double dash will be lying onto the same line, because Q point is also available with us at a height of 30 millimeter above the horizontal plane. Now the location of the point Q is 60 millimeter behind the vertical plane. This is 60 millimeter behind the vertical plane. Now this distance we can see, this distance happens to be 60 millimeter behind the vertical plane. That is, from this point to this point, this distance is 60 millimeter behind the vertical plane, because behind the vertical plane means this will be projected above the XY reference line in the second quadrant projections over here. So this has been projected 60 millimeter behind the vertical plane above the XY reference line in the second quadrant projection. Now what we are going to do, from this point Q, we are going to draw a horizontal projector line, extend it till it meets this particular 45 degree inclined transfer line over here. So as we draw a horizontal projector line through this, now we can see this 60 millimeter height, that is behind the vertical plane distance, has been converted into 60 millimeter behind the vertical plane distance into the horizontal direction. Because of this angle of inclination of 45 degree, so this distance of 60 millimeter height, this has been converted into 60 millimeter behind the vertical plane, because this distance now happens to be 60 millimeter. So this is the distance 60 behind the vertical plane. Now you can see this distance is 20 millimeter in front of the vertical plane. This distance happens to be 60 millimeter behind the vertical plane, so that the total distance between points P and Q happens to be 80 millimeter. Now, so from this point, we are going to drop a vertical perpendicular projector, extend it till it meets the horizontal construction line or the projection line drawn through the point Q dash. So this we have drawn horizontal line through Q dash. This is the vertical line drawn through the transfer point corresponding to the point Q. So wherever this vertical projector and this horizontal projector line they intersect, we obtain the location of the point Q double dash over here. So now once we join P double dash with Q double dash, now we will observe P double dash point. It is located at a height of 30 millimeter, distance of 20 millimeter in front of the vertical plane. Point Q double dash is drawn at a height of 30 millimeter and 60 millimeter distance behind this particular vertical plane over here. So this way, the height of points P double dash and Q double dash above the XY reference line happen to be 30 millimeter. Therefore, the projected length P double dash Q double dash happens to be parallel to the XY reference line or the horizontal plane. So this projection happens to be the true length projection. So the side view projection P double dash Q double dash, it is the true length projection of the line PQ. The top view projection PQ of this line, it is also the true length projection, whereas the P dash Q dash, that is the front view projection obtained at a height of 30 millimeter above the XY reference line onto the vertical plane, this represents the point view representation of the projection onto the vertical plane. So the front view is point view, the top view happens to be true length, and the side view also happens to be true length. So this way we have been able to obtain the projections of a line when 1/4 of the line, we can see it lies in quadrant number 1, and 3/4 of the line, it happens to lie in quadrant number 2. So these are the orthographic projections of the line PQ, corresponding to which the ends P and Q, they happen to lie in the different quadrants over here. So this is all for today. So we will be continuing with further discussion on few more illustrative examples related to the projections of the lines in the coming lectures. Thank you very much. Thanks a lot.